Heat transfer. Heat is a form of energy which can be transferred from one part of the system to another part due to temperature difference between them. Heat can be transferred from one place to another by the following three models. 1. Conduction. 2. Convection. 3. Radiation. Conduction. It is a mode of transfer of heat energy from one part of a body to another part at low temperature without actual motion of the molecules. Explanation. According to kinetic theory, the molecules of a solid are in a state of oscillation about their fixed positions. When one end of a metal rod is heated, the molecules at heated end absorb energy. Therefore, they vibrate about their equilibrium position and interact with neighbor molecules. Thus, they transfer a part of their energy to neighbor molecules. These new molecules in turn transfer energy to other molecules and so on. Thus, heat energy is passed along the rod from molecule to molecule without changing their fixed positions. Conduction usually takes place in solids, copper, silver. Gases are poor conductors and liquids have conductivities intermediate between solids and gases. Mercury, being a liquid metal, is a good conductor. Thermal conductivity. Thermal conductivity of a solid is a measure of the ability of the solid to conduct heat through it. Consider a metallic bar of length L and uniform cross-section A with its two ends in the thermal contact with large reservoirs at temperature Tc and Td. Tc greater than Td. Heat is conducted through the bar from hot end to the cold end of bar. After some time, a steady state is reached. The temperature of bar decreases uniformly with distance. The reservoir at C supplies heat at constant rate through the bar and is giving out at same rate to reservoir at D. During steady state, the rate of flow of heat, H, directly proportional to A, area of cross-section. H, directly proportional to Tc minus Td, temperature difference. H, directly proportional to 1 by L, length of bar. H is equal to Ka into Tc by Td by L, where Tc minus Td by L is called temperature gradient. The constant K is called the coefficient of thermal conductivity of material of bar. K is equal to H by A into Tc minus Td by L. If A is equal to 1, Tc minus Td by L is equal to 1. Therefore, K is equal to H by A. Units W and inverse, K inverse. Therefore, coefficient of thermal conductivity of material is equal to rate of flow of heat per unit area per unit temperature gradient across the material. The value of K depends on nature of material of the solid. The value of K is large in case of good conductors and is small in the case of insulators.